Here's the deal. The question is, as you see it, I believe if you're unbelievably on your game, you can figure it out yourself. So that's what you should. You should say, yeah, I can. And so that's what it is. I honestly, the way I teach is a product of how I was as a student. I resented it all get out when the teacher just said, here's how you do it. Copy it. I hated that. I would rather figure it out myself or not figure it out at all. Okay, so that's what I want you to do. Figure it out on your own, or with your math amigos.
Oh, I don't use my math amigos. I was kidding. I know, I'm trying to get one.
All right. Oh, my coffee. Because these are all half circles. These are both half circles.
Yes. And then what's that?
just don't even know how to do it in terms of y. Can we do it in terms of x?
How we doing? We have an
Not
answer for you.
trying.
Got it?
No.
What's the problem?
Because you said it's
The whole thing
use
is
the other variable that you would have used for this or watch this.
And so I don't know.
You don't use that?
I don't use that variable.
You don't use that variable?
I don't know what it is.
Okay, well, let's go here. Do you agree the graph looks like this?
Yes.
Okay. And if we go around the y-axis, we would typically use y, yes?
Correct.
All right, so if we use y, we'd get a washer, and everything seems like it's going swimmingly.
It seems that way.
Okay, so why not? What's the problem?
I don't know how to.
Yeah, the bounds are hard. That would involve finding maximum, so I could work my way on that. That's not a problem. What's the problem?
Read in terms of
Yeah.
y.
Yeah, solve that for us in terms of what? Actually, it wouldn't even be, let's go here. If I took x equals y squared, actually, let's go just straight up. Y equals x squared. If I made that parabola in terms of y, how many functions? X is plus or minus y, because, root y, because you need one for basically every piece that fails the horizontal line test, yeah? Well, here you would actually need to make, oh, shoot. Okay, you would need to make actually 1, 2, 3. That would be, in terms of y, that would be 3 different functions. And you'd have to figure out how to solve that for y, which, at the end of the day, the moral of that story is y is not going to happen. That's the first conclusion I hope you're going to make. Why? It's not happening. Now, then the question is, all right, does that mean it's not possible? The answer is no, it is possible. Of course it is possible. You just can't use y. So, what do? You use x. Okay, well, how does that change things? This is where I've been begging you, please draw a slice. Draw a slice. Use x, draw a slice. And then think geometry. when you have an answer, you may use a calculator. Now, it's very tempting to think of it still in a washer way of thinking, but that is not the way to go. This is the way to go. Let's see, how can I make this look like that? Oh. Wait, let me finish. Oh. Answer? Not quite yet. Innovation's not terrible, but you may use a calculator if you want to. Oh, I told you it was an integral, darn it. It might be a derivative. It's not. All right. So we have success. You guys need another second or move on? Okay. So the big idea by far, first of all, there are really two big ideas of shells. First of all, they weren't created just for more fun. They were created out of necessity. There are some problems that shells and discs, washers and discs, they just don't work for. You've got to have some other way to deal with what happens if I want to use the other variable and it's revolving. When you use a variable that's parallel to the axis of revolution, in this case, a slice is parallel to the axis of revolution. It's not so much a washer as a really empty piece of paper like this. And to find the volume of that, you unwrap it, making it like a very thin rectangular prism. Okay? It's the sum of many unrolled cylinders and the volume of those. Now, there will be a length and a width and a height And of those dimensions, one of those dimensions will always be a paper thin, dx or dy. In this case, dx, okay? So one thickness, I'll call it the, I don't know what you call it, but one will be dx. It's all relative what you call which. Okay? This guy, this corresponds to the circumference. That bottom edge corresponds directly to the circumference. And so one of the dimensions will be the circumference, 2 pi r. And the height of these sheets, well, that goes right there. And what's going on there? What's that about? The function. All right then, so that is the big picture. Details then, 2 pi. Let's go, the 2 pi can be brought up front. That's no problem there, it's constant. The radius. Is the radius of all these shells the same, or is it constantly varying? Varying. And is it varying x or varying y? X. So horizontal distance x. The height is, seems like it's just here or here, isn't it? Just the distance from the axis up to the function, which in this case is x times x minus 2 quantity squared. The thickness of the sheets is dx. The limits of integration. Make sure that when you do the limits of integration, just like all volumes, they correspond to the original region, not the revolved region. So a very common error when people say, well, my picture is going from -2 to positive. No. It's about the original region, and the original region goes from 0 to 2. That's where you're getting x's the revolve. That then is your volume. That's the idea of shells. Are you with me so far? Cool. All right. This is a little wordy, but this is what I want you to understand. Okay? You're going to have 2 methods now. And students every year, we'll practice this Thursday, but every year it's the same. They say, oh, should I use shells or should I use washers or should I use... That's not the question. I never once have asked me, should I use shells today? The question is, what variable do you want to use? Then, that decides what the method is. It's about what variable, not the method. Okay? So let's consider x equals sine y. What does it look like? X equals sine y is what? Oh, sure, you're drawing it in the air, which I can't see because I'm facing this way. But do you agree it looks like this? Oops, no, it doesn't. It looks like this. Oui? All right. Now I'm talking just the part from 0 to pi. And it's revolved. If it were revolved around the y-axis, boy, that'd be great. I'd use this, no problem. But if it's revolved around the x-axis, then I get this kind of shape, a B kind of shape. You with me? All right. Now, in the past, I've just thrown this to students, and they said, well, if I revolve it around the x, then I use x, and my slice looks like that. And they don't see any problem. They say, okay, sounds good to me. Washer, I got that. Volume is pi big R squared minus little r squared dx. Cool. And big R is here. Now, big R is the distance from the axis to the curve. And in x terms or y terms, right? Which one, x or y? X, okay. So what's the equation in x terms? Arc sine of x, and that's big R, yeah? All right, little r. Here's little r. Little r is the distance from the axis to the, oh wait, the curve. And the little curve, the curve r. Well, the curve in x terms is, yeah, arc sine, again. Oh wait, now wait a second. That doesn't look right, and that's, of course, terrible. The problem is that arc sine is not a single function of x. Okay, arc sine is only going to go from here to here. Are you with me? If I wanted to, you know, if you appreciate how much, if I wanted to write big R, then wouldn't I need this part of the curve, this blue part? To write, this goes back to fancy graphic calculators. To write, this is arc sine of x equals y. If you wanted to write the equation to that, you would have to start with the arc sine curve, reflect it, and shift it up pi over 2. And so it would be more like negative arc sine of x plus pi over 2 equals y for that blue curve. Arc sine is defined as a very limited region, and if you want to move it up there, you have to start shifting it around and making copies of arc sine and moving it all around. Then you could do function minus function. At the end of the day, I think you'll agree that x is a stinking mess. Do you agree? All right. If x is a stinking mess, x is a mess, then let's use y. Now, if I use y, let's start with the slice. What does a y slice look like? Is it vertical, which would make sense, it's y, or is it horizontal? It's a gotcha question. Everybody wants to say, well, if it's y, it has to go that way, right? Is that dy thick? No, that's an x slice. A y slice actually looks like that. When you make a dy slice, don't think vertically, think thickness. Thickness vertically is dy, and that revolve would not make a washer, but a cylindrical shell. When I unwrap it, because that is the idea, then I want to find the volume of that guy. This thickness here, it becomes this dimension here, and what is that? dy. Okay? This circumference here, when unwrapped, becomes that length, which is 2 pi r. And will that radius be x or y? Y. It'll be y. And this distance here, or this distance here, or this distance here, or this distance here, that's going to be my bottom part of the rectangle, and that's the function in x terms or in y terms? In y terms. All right, so if I go to collect all those volumes, now remember it's not so much one piece of paper, but a whole roll of papers stacked. It's more like this huge thickness, and that together makes, with lots of little pieces of paper, makes a pretty thick volume. So it's the sum of these, which is where integration comes from. 2 pi, what? 2 pi y times sine of, arc sine of x or sine of y? We want the curve, but we want it in y terms. So sine of y dy from 0 to pi. Okay, let's have you try one on your own now that you are feeling the principle. You may use a calculator once it's set up. Please, I beg you, graph it, say what variable do you want to use, and then show a slice for that variable. You have something like that, are you getting? Okay. We definitely would want to use x here. I don't want to solve a parabola and break it into two square root functions. It's ugly. Sometimes you have to complete the square to do so. It would just be gross. So you definitely want to use x, and when you revolve an x slice, it becomes a shell. Cool? Cool. All right. Let's skip this in the interest of time, and let's try this one together. This one is pretty rough. All right. So x equals y minus 2. What kind of graph is it? It's a parabola opening up and down or side to side? Side to side. Shifted how? Okay, so this is where I suggest don't memorize anything and just say, do you agree that the least a square can be is 0? Do you agree that that's what makes the bottom of a parabola is where the 0? Because the least a square can be 0, right? What makes this 0? When y is 2. 2, 0 is the vertex. Okay? Memorize nothing. Think conceptually. All right, so it's opening sideways. And like that. Negative x plus 4 has a y-intercept of 4 and is down 1 over 1. So if I graph that, it feels like I'm getting that kind of situation. You agree? The region enclosed then looks like this. Okay. That's right. All right. Now, if you revolve that around the x-axis, then my first question is, okay, I got the region, and I might try and draw the three-dimensional figure, but I think I might make a picture that would confuse me, so I'll leave it. My next question is, all right, do I want to use x or y? Well, what do you think? If you do this in terms of x, won't it have to be a positive square root and a negative square root just to make the parabola, and then you'd have a third equation for the line? Yes? And you'd actually have, if you used x, you'd have two situations. One where you're talking upper minus lower curve, and then another where you're talking line minus curve. X is a mess. X is a mess. You've got two different situations, three equations. It's a mess. What about y? Well, if I use y, the slices go this way. And that parabola actually can be just one equation of y. I don't need to break the equation into two separate equations of y. It's fine as one. So it feels like y is a much better variable to use. This one is already written in terms of y, and I could easily write this in terms of y. So it feels like they're pretty easy to use in y and not so easy to use in x. So I'm going to use y. And then the next thing I'd say is if I use y, then I get a slice like this. And if I revolve a slice like that, what's made? Was that a washer or a cylindrical shell? Yeah, now that's a cylindrical shell. And I know every year it feels like the students feel like, I mean, I don't get it. Doesn't it feel like two circles and one's inside the other? It feels like washer to me. It's not a washer. Washers are super paper thin, and most of the volume comes from the area of the surface. The cylindrical shell's totally different. It's more of a tall paper thin, and the volume comes from the sides mostly. So they're not the same. Don't think, well, a circle within a circle, it's always a washer. That's not necessarily the case. Cylindrical shell is also that. All right. So, great. I'm going shells. Now what? Now what do I do? I what? I'm going to unwrap it just for a second. Okay. So let's go this dimension. What's this thickness? T1. Okay. What's this dimension? 2 pi r. And what is r? Yeah, I feel like no matter where I draw this, here's the radius or here's the radius. It's not constant, it's varying, but it is just, seems like just a y, yeah? All right, hardest part is this part. What's this dimension corresponds to this, or this, or this. Look at those segments. They're all over the place. They have varying right endpoints. They have varying left endpoints. How do we find out how long that is? Right minus left. Yeah, right varying point minus left varying point. What's the right? And, sorry, go ahead. What's the right? Negative y plus 4. It's the line. Yeah? And the left is the parabola, and all in y terms. So line minus parabola in y terms. Now I'm ready to go to my calculus. Volume is 2 pi y. And that crazy horizontal distance is right minus left, and closing in parentheses. So I make sure I subtract the whole thing. What is right? 4 minus y. What's left? Y minus 2 squared. dy. Limits of integration. Uh-oh. I do not know the limits of integration. How do I, 0 to 3? You taking a stab at it, or you know that to be true? How did you know it to be true? You set them equal to each other? You did that while I was doing all this yapping? You already solved it? Okay, so I feel like, do I trust you? I do? Y squared minus 3y equals 0. I trust you. Y is 0 and 3. The limits of integration are indeed 0 to 3. You do have to find that. And boom, you're rolling. Okay, you with me? Last but not least, I gotta be honest with you, you could be a total clown and get volume by discs and washers correct. And that's because you might have set it up wrong, right minus left, or upper minus lower, and you really are getting a negative distance, but the square washed it out. Because you do definitely have a square in your disc and washer. And so this often cancels out poor calculus on the AP test. Of course, on my test, I would absolutely nail it for that. I don't care if it came out right. Your calculus is garbage. On a shell, there is no square. It's basically 2 pi r times the height. And if you set it up wrong, you will get a negative volume. Shells done badly, you might get negative volume. That should not happen. You have an error. You screwed it up. Usually it's some kind of right minus left or upper minus lower, or you didn't consider the function was negative kind of thing. So let's take one last look at a problem, and then we'll call it good. Y equals x squared minus 2x. It is a parabola opening up this time with a x-intercept of 0 and an x-intercept of 2. If I revolve it around the y-axis, then it looks like that. It's already a single function of x, but it would be 2 functions of y, so I definitely want to use x, a single function of x. So use x. If I use x, then my slice goes this way. If a slice that way is revolved, I get this kind of figure. Disc, washer, or shell. This is a cylindrical shell. So, if I get a cylindrical shell, then I unwrap it and identify the components. The thickness is dx or dy. Dx. The bottom edge is 2 pi x in this case for the radius. And the height is the function, right? Wrong. The negative of the function, because the function is negative. And if you just go 2 pi function, you will get a negative volume guaranteed. The function is negative. This height, upper minus lower, or 0 minus the function, or the opposite of the function. You've got to deal with that one. So we're looking at volume is 2 pi x times, rather than x squared minus 2x, let's go 2x minus x squared dx from where to where? 0 to 2. Okay, good deal. That's it. Let's get out extra practice 85. We're a little behind the other class, so let's roll. Would you get out that fun sheet of extra practice 85? It was not a fun packet, I remind you. It's a fun sheet, not a packet. All right. This here, this table problem, it's kind of famous in that it is the AP Calculus problem with the lowest averages in the history of AP Calculus problems. The average on this question was less than a 1 out of 9. Exactly. Now, if you're thinking, why? It's not that hard. You're right. It's because you'll find that, well, they're nice kids. Many people taking the AP test are total knuckleheads. They're not as brilliant as you, and so always remember that. Keep in mind you're trying to separate yourself from the knucklehead. All right? It's not their fault. They're in some kind of farm community where the gym teacher's teaching them calculus and he's doing the best he can. So who's to say? This. Why must there be a place where the function is -5? What'd you use? IVT. Now, it might have been, to meet the conditions, you might have felt like you were kind of hoping something was true or making up now. It is true that H is continuous, and why is it continuous? It doesn't say that. Because F and G are differentiable, so they are continuous. Now, you don't actually have to do it, thankfully, you don't have to do a rigorous proof of that fact. You just have to kind of state, hey, I know it, it's a condition for IVT is that H is continuous. And you say it and you kind of hope it's true, and it actually is true. Continuity is achieved. So, the next thing you would probably need to get into is what is H at 1 and 3? So, you needed to find H at 1. What did you get for H at 1? Somebody? 3. And what is H at 3? -7. And -5 satisfies the betweenness element of IVT, yeah? So with that, you'd say something like H is continuous, and that H of -5 is between the two values they give us, which is H at 3 of -7, something along these lines. H at 1 is 3. So by IVT, and then I just regurgitate the question out. There is an R between 1 and 3 where such that H at R is -5. Most people do fine with that. Are you good?
Do you have to rewrite that as continuous if you already have it there?
No. If you have it once in your work, that's okay. If they say, why must there be a value such that the derivative is -5? What's that a reference to? Mean value theorem. That's MVT. Okay, now, I don't know about you, but I just started kind of plowing ahead, and I hope it all worked out. I have no idea where -5 comes from. I just assume it'll kind of pop up when I start my MVT work. What are the conditions? H is continuous on 1 to 3 and differentiable on 1 to 3. That's the first point in the rubric. Meets the conditions of MVT. So by MVT, there exists a C in 1 to 3, if you like to get fancy with the math symbols, such that H prime at C is H at 3 minus H at 1 over 3 minus 1. Did you eventually see that -5 pop up? Yes. Yes. Can you imagine your confusion if you messed up one of these values? Because if you messed one of those values, the -5 would not pop up. And you're thinking, what? No. Now, in that case, you would actually conclude, no, there is not such a value guaranteed. And you would be correct on part B if you concluded correctly based on your part A. All right, so do you agree that you get -5? Okay? This one required the chain rule. The chain rule, and you should have -2. Did you get -2, or do we want to talk about where that's coming from? Okay, so I don't know about you. You could do this without the same work I'm doing, but I was taught to do this way. Something like, I can't find W prime unless I flesh out this a little bit. I'm going to let capital F be the antiderivative of little f. That's pretty common notation in most calculus, at least in America. Therefore, W of x would be 1 to g of little f would be the same as capital F, the antiderivative at g, minus the antiderivative at 1. Yes? Okay. Now, if I then took the derivative, then when I take the derivative over here, I'm taking the derivative of capital F, which is the derivative of the antiderivative, which is just f. At the inside the same, but then by chain rule times the derivative of the inside, g prime of x. What about this? When you take the derivative of that, it zeroes out. You're saying that the derivative, it wouldn't matter if this were 1 or a billion, it would still be the same derivative? Yes, the area accumulation would not depend on where you started. The rate of area accumulation. All right, so with that then, you're plugging and chugging, W prime at 3, you plug stuff in and chug, chug, chug. Do you understand what I mean when I say chug, chug, chug? Okay, good. All right, last but not least, must there be a place such that, this is the third existence theorem. There's IVT, MVT, and EVT, the extreme value theorem. Think of it like this. There must be a y value greater than or equal to all random y values, which is to say there must be an absolute max. What are the conditions for EVT? We know the conditions. Continuous on a closed interval. Okay? Now, also keep in mind, they're talking F here. F is continuous on a closed interval. So by the extreme value theorem, there must be an absolute maximum. I just said there must be an absolute maximum. But if you wanted to parenthetically say some y value greater than or equal to all other y values. That is the idea behind it. Okay? And you're just showing you understand what all those symbols mean. Very cool? Okay. This one is E. Are we cool with that? Or should we talk about that? We're cool. Okay. This last one on the first page got a few people. This one goes to test strategy. I like just good math, but there is a place for test strategy, and this is the test strategy I would suggest here. All right, you got a function, blah, blah, blah. What are the values of C that satisfy the mean value theorem on -1 to 2? Before I even start the problem, tell me what answers can go, must go. A has to go. Why? It's not an interval. That cannot be an answer. It's got to be an interval. Okay, what else? 8, gone. Both gone, no chance. Okay, now that actually is probably the answer that many people would circle, because when you do the mean value theorem here, you get something like 2 over C plus 2 squared for the derivative, and the other side is something like, I can't remember, 1/2. That, when you solve it well, you actually get 0 and -4 for solutions, but you should have scratched -4, because man, it's tempting, after doing all that work, to see your answer there. It's tempting to bite on that. That's why you scratch impossible choices first. Okay. All right. This one is also a classic. Oh, what happened there? Did you see that? Yay. Okay. For part A, please be careful here. If you said acceleration at time 5 is this, then the minute you wrote this, you're out. Okay? It should be approximation. A at 5 is approximately equal to the change in velocity, which is v at 10 minus v at 0 over 10 minus 0. What if somebody used different points, like 0 to 60? Why would that violate the idea of the derivative? What's the first part of the definition of the derivative? The limit as goes to 0. The whole idea of the derivative is you get as close as you possibly can to the point of interest, and that's what the limit's there for. If you were to use 0 to 60, you're not using that limit idea. You're not getting as close as you can to the point of interest. So it should be something like 10 and 0 only. And did you get something like 0.03? And what are the units there? Meters per second per second? So meters per second squared? Yes? Okay. What is the meaning of integral of absolute value b? Total distance. Okay, so the integral of this expression is the total distance, what it is with units, when it is with units. So the total distance in meters that Ben travels from when to when? Time equals 0 to time equals 60, or 0 to 60, but you did have to show the units and they were seconds. Okay? I bet I got a couple of you with C. Did you say no? Ben's velocity, must there be a time where Ben's velocity is 2 meters per second? Because you looked at 40 to 60 and you looked at his velocity and said, hey, looky there. 2's not in there. So by IVT, nope. But you got it wrong because you thought IVT. You should have thought MVT. What's the average rate on that interval? The average rate is 2 meters per second. And so, must there be a time when he went to? Yes, there must. By MVT, not IVT. All right, I will keep it, we'll finish going over it. Tomorrow, I have a senior day planned because the juniors won't be here. So, bring your, I don't mean seniors like woo-woo party, I mean you're going to work on your college applications or college scholarships. So bring what you need to bring. I will have some computers for you. I will check out a Chromebook cart or case or something. And juniors, good luck. Hey, you guys have access to like practice tips, right? Yeah. Okay, so I don't need to make stuff up here because I got that. Okay, good. Yes?
Your performances is...
My board says what?
It's like performances 87 part 1, 87 part 16.
Yes.
So we just wanted to show us.
Did you not get your homework?
No, we didn't. No, we
Oh,
didn't.
yeah, that's part 1. Part 2 is volume punching.
So this is due Thursday.
Yes. Yes. That means to blow it off. So
That means I
Thursday lunch.
said it.
Thursday, 5th period. 4th, 5th period
Yeah.
teachers. That's pretty bad.
Thursday.
All right.